Good morning one and all, welcome to my channel Miracles of Math. So we will continue with the topic sets. In the last class we learned what is union of set, intersection of a set. So we'll see some more properties based on that. The first law in this topic is idempotent law. Idempotent. So in that you have one with union and one with intersection, and the other property is identity law. Identity property. A union phi. What is phi? Null set. A union null set, and this is A intersection U. What is this U? Universal set. This is not union. A intersection with universal set, you will get the set A. We'll see what are these. Let us take one example. Set A consisting of the numbers 1, 2, 3. A union with A. So once again, you have a union with the same set. Union means you need to take all the elements present in all the sets. Union represents you need to take all the elements present in all the sets. So A union A. A union A. What is that? All the elements present in both the sets 1, 2, 3 as well as 1, 2, 3 again. So you get the same set again, that is 1, 2, 3, which is simply nothing but A. A union A is equal to the same set A. In the same example, if you go for A intersection A, what is A intersection A? This one and this one. What are the common elements between these two? As these two are equal sets, all the elements are common between them. All the elements are common in between them. So A intersection A will give you the same 1, 2, 3 again. That is again the set A. That is again the set A. So this is about idempotent. And there are two more in identity. One with union and one with intersection. Let us quickly see what are these. A union phi. What is phi? Null set. There is nothing in that. There is no elements in that phi. Let us take the same example. A is equal to 1, 2, 3. Phi means it is just an empty bracket. Empty bracket. Okay. So A union phi. A union phi. Union means what all the elements are present in A as well as phi. You need to write all. You need to write all. So you will write 1, 2, 3, 1, 2, 3, and the elements in phi. What are the elements in phi? No elements. It is an empty set. There are no elements in that. So it is phi. Okay. So this same set we are getting. So it is simply equal to A union phi is equal to A. In the same way, the next one, A intersection universal set. What is universal set? Universal set is a parent set of what we are actually considering about. All these sets are coming from some parent set, that parent set. Let us take universal set as set of all natural numbers. Set of all natural numbers. Don't write like this. Okay, set of all natural numbers. I'll write it again. So universal set is 1, 2, 3, so on till infinity. What is the before one meaning? I wrote set n. That means n is the element in that. No. All the natural numbers are the elements in that. A intersection universal set. And what is A? A is equal to 1, 2, 3. So intersection means the common elements between these two. What are the elements common between these two? So just by saying you can say that only 1, 2, 3. All the elements in A are common in the universal set. So A intersection universal set will give you again A. So the same thing. These are the first two laws in sets, that is idempotent and identity. So we'll move forward. Alright. So the next two properties of the laws are commutative law and associative law. What is this commutative law saying? A union B is equal to B union A, and A intersection B is equal to B intersection A. If you relate this to the normal mathematics, the normal number system, commutative law in that, what is that? 1 plus 2 is equal to 2 plus 1. That is commutative law under addition. 1 into 2 is equal to 2 into 1. That is under multiplication. The same thing will come here. Okay. So what is A union B? If you have two sets, A is equal to, let us say 1, 2, and B is equal to, let us say 2, 3. So what is A union B? What is the meaning of A union B? You need to take all the elements present in A as well as in B. So what are all the elements present in A? 1, 2. In B, 2, 3. 2 is already mentioned here, so no need to write it again. So it is 3. It is A union B. What is B union A? The same thing, right? B union A means again the same elements, whatever there in B and A clubbed together. So 1, 2, 3. All the elements will come. So these two are always equal sets. A union B is equal to B union A. In the same way, tell me what is A intersection B here? A intersection, what is the common between these two? Common element is 2. Intersection always comes for common elements. So the common element is 2. What about B intersection A? Common between A and B or B and A, both are same, right? Just the common element. So again from B and A, the common element is 2. So these two are again the same. These two are equal. A intersection B is equal to B intersection A. This is commutative under union. This is commutative under intersection. The next one is associative law. What is the difference between these two? So this refers only with two elements. 1 plus 2 is equal to 2 plus 1. 1 into 2 is equal to 2 into 1. In that way. Associative. Associative is like with three numbers. You add 1 plus 2 and then to 3. Or you add 1 to the sum of 2 plus 3. Anyway, both of them will give the same answer. Here also will get 6. Here also will get 6. So you are getting the same answer. In the same way, intersection, let us say 1 into 2, I am just bringing an equivalent terms in normal number system. 1 into 2 into 3 or 1 into 2 into 3. Are these two same? Yes. It is also 6, it is also 6. Yes or no? So this is what associative law says that. You take union of first two and then for the final result you again take union with C, or you take the first union of B union C, B and C union, and then you do a union with A. You will get the same answer. Let us quickly see with small example. A is equal to 1, 2, B is equal to 2, 3, and C is equal to 3, 4. Tell me what is A union B. All the elements in A and B should be written here. All the elements in A and B should be written here. What are all the elements? 1, 2, and 3. So 1, 2, 3. No need to write 2 times. Writing 1 time is sufficient in set. What about A union B union C? That means this set 1, 2, 3 union with the set C, that is 3, 4. So what are the all elements, right? Listing all the elements. Okay. So 1, 2, 3, 3 is already there, 4. So A union B union C will give you 1, 2, 3 and 4. 1, 2, 3 and 4. Correct. Now go for B union C. What is B union C? B union C is 2, 3, 4. 2, 3, 4. And so what is A union B union C? That means you need to take a union of A and B union C. What is A? That is 1, 2 with B union C, that is 2, 3, 4. So what is the union of these two? 1, 2, 3 and 4. Are these two equal? Are these two equal? Yes, these two are always equal. That means you take a union of first two and then with the third, or take the union of second and third and then union with first, you will get the same union of elements. You will get the same union of elements. The same example you please try with intersection. A intersection B. What is the common element? 2. And that intersection with C. In this case, you will get 5. Okay, no common element between all the ABC. But take some other example and try for A intersection B and then do A intersection with C and find B intersection C and find with A. Simply saying what are the common elements between A and B and that with C. That means we are taking the common elements between A, B and C. All the common elements between A, B and C. The same thing here also we are doing. First we are finding what are the common elements between B and C, and to that result we are finding what are the common elements with A. Simply the common elements between A, B and C. We are talking two different cases and both of them surely will be equal. They will be equal for sure.